Lesson 4.5, Isosceles and equilateral triangles. Here is an isosceles triangle. The vocabulary needed are legs. Legs are two congruent sides. The base is the third non-congruent side. There is a vertex angle, and it's the angle in between the legs, and the base angles are the two angles that touch the base. These vocab words will be important in using your theorems today. Here's our first theorem, the isosceles triangle theorem. If two sides of a triangle are congruent, then the angles opposite those sides are also congruent. The converse of that, if the two angles of a triangle are congruent, then the sides opposite those angles are congruent. So both of these will be helpful in proving triangle congruence because we get more corresponding parts congruent. So let's look at this problem. Is AB congruent to CB? Explain. Well, the first thing that I notice is that the smaller triangle is isosceles because it has two sides the same. So then by the isosceles triangle theorem, these base angles are congruent. So we'll go to part B. Is angle A congruent to DEA? And we will say yes. And the reason for that is because of the converse of isosceles triangle theorem. If you forget that name, just write down what you know. So what we know is that if the sides are congruent, then the angles have to be congruent. And then maybe you should write the word isosceles down so I know that you think this is an isosceles triangle. Up above then it says, is AB congruent to CB? Well, I see angle A and angle C are already marked congruent, so that makes the bigger triangle isosceles. So we know that that one is isosceles because of the isosceles triangle theorem. Here's another example. Is angle WVS congruent to angle F? Explain. So in purple, there is WVS. We're trying to decide, is it congruent to this angle right here? And I would say yes, because the sides are congruent, then that has to have base angles congruent. So that's the isosceles triangle theorem again. Now we're trying to decide, is TR congruent to TS? So those are the purple segments. So now we have the base angles congruent. So if the base angles are congruent, then the sides are congruent because of the isosceles triangle converse. And you could write it as isosceles triangle converse or converse of the isosceles triangle theorem, whichever suits you. Can you conclude that triangle RUV is isosceles? So here's the triangle we're looking at in green. RUV, we have one angle congruent. We don't know that RU and UV are congruent at all, so I would conclude that no. We have no information. For the next two problems, we need to review the theorem. You might want to write these notes down. The exterior angle theorem. A measure of an exterior angle of a triangle is equal to the sum of the measures of the two non-adjacent interior angles. We have already learned this. So in this picture, 4 is the exterior angle, and 4 is equal to the sum of 2 plus 3. Pause the video if you need to write this down. So if we apply the exterior angle theorem to question number 5, here's what we get. 1/15, the exterior angle, is equal to the measure of x plus the measure of y. The other thing that I noticed from this day's lesson is that this is an isosceles triangle. So then our base angles have to be congruent. So what do you think we could find first? I just don't think we can do anything with this problem here because we have two variables. So you're right, we should find x first. So 115 and x form a linear pair, and linear pair postulate says that all linear pairs are supplementary. So 180 minus 115 gives us 65. So x is equal to 65. So we have one of our variables solved. So now if I plug in 65 to this piece of information here, then 115 minus 65 is 50. So y would be equal to 50. Without using the exterior angle theorem, you could also use triangle sum. Once you have both of these at 65, then you could add all three of those angles together and they would have to equal 180 because of the triangle sum theorem. Try number 6. Pick your method. Pause the video here and turn it back on when you're ready for the answer. So in this problem, what I decided to do was use linear pair postulate first to get x is 45. Well, 45 is a common number in triangles. So 45 and 45 because isosceles triangle theorem, so that makes 90. So if you have 90 here, triangle sum theorem would leave 90 for y. So in that one, I did not use the exterior angle theorem, but it's a good one to remember. Theorem 4-5. If a line bisects the vertex angle of an isosceles triangle, then the line is also the perpendicular bisector of the base. So in our picture, if this line is the angle bisector in an isosceles triangle, it's also going to be the midpoint down here. So let's see if we can use that. In this picture, we have DB, and it turns out to be the angle bisector. And our goal is to figure out what x is. So in the picture, I would say the blue angle is 54. Because this is an isosceles triangle, the isosceles triangle theorem says that the base angles have to be congruent. So this one would also be 54. And then whatever x is, x would also have to be the same here. So we do end up with congruent triangles by ASA. Or we could use theorem 4-5 to get these two sides congruent, and then we would have some other options. And also by reflexive, these two sides are the same. But we still have to figure out what x is. So if we look carefully at that theorem from the previous page, it says something about it being perpendicular. So yes, it hits at the midpoint, but it also makes a 90-degree angle. So if we go back to our picture, that means we have a 90-degree angle here and here. So now we can use triangle sum. So in our triangle, we have 90 plus 54 plus x, and that has to give us 180. So x is going to have to be 36. Try the bottom one on your own, pause the video, and turn it back on when you're ready to see the answer. Again, by theorem 4-5, we get a perpendicular angle. So by triangle sum, our missing angle has to be 63 degrees. This concludes my lesson.